Here we have a bunch of clips of some really great athletes doing a lot of jumping, and that's what this video is going to be about. The simple act of jumping. Although jumping isn't simple, it's a complex full body movement. We're going to break it down into one part of that movement, the ankle, and more specifically, the muscles that are attached at the ankle and what they're doing during jumping. Jumping can be broken down into three distinct phases. Preparation, which looks like this. Takeoff, which looks like this, and landing, which looks like this. And before we go into each one of these muscles and what they're doing in each one of these distinct phases, I want to do a quick explanation on what I mean by the preparation phase, the takeoff phase, and the landing phase. During the preparation phase, the ankle bends so the toes move upward towards the shin. This is called dorsiflexion. This movement stretches the calf muscle and the Achilles tendon. By briefly holding this loaded, stretched position, the ankle acts like a compressed spring, preparing to use the stretch shortening cycle to release explosive energy. During the takeoff phase, the ankle powerfully extends by pointing the toes downward and lifting the heel off the ground. This is called plantar flexion. This contraction drives maximum force into the ground, transferring the energy generated by the hips and knees and converting it into upward propulsion. And during the landing phase, the ankle immediately bends back into dorsiflexion, allowing the muscles and Achilles tendon to stretch and slow your momentum smoothly. This acts as a critical shock absorption mechanism. Proper ankle mobility during this phase prevents your knees and hips from having to absorb all the impact, significantly reducing your risk of injury. Our first set of muscles will be the plantar flexor muscles, which are the muscles in the back of the leg. These muscles pull the heel up and point the foot downward. The first muscle we are starting with today is the gastrocnemius muscle, the gastroc for short. During jumping, the gastroc acts as an explosive force generator. It contracts to forcefully plantar flex the ankle, transmitting power through the Achilles tendon to propel the body into the air. In the preparation phase, you'll see here your ankles dorsiflex, which means they bend upward. This puts the gastrocnemius under a heavy stretch while it prepares to generate force. The muscle fibers actively contract, building up elastic tension. During the takeoff phase, the gastroc undergoes rapid concentric contraction. It acts as a biarticular muscle because it crosses both the ankle and the knee joints. During this phase, it assists in extending the ankle to push off the ground, that plantar flexion, while helping to stabilize or extend the knee, which translates directly into your jump height. And then in our final phase, the landing phase, once airborne, the muscle relaxes. Upon landing, it acts as a shock absorber, working eccentrically to control the forward movement of the shin and safely deaccelerate your body weight. Our first set of muscles will be the plantar flexor muscles, which are the muscles in the back of the leg. These muscles pull the heel up and point the foot downward. Here we have the soleus muscle. The soleus muscle lies underneath the gastrocnemius, acting solely on the ankle, unlike the gastroc that acts on the knee and the ankle. During jumping, the soleus acts as a primary stabilizer and powerful force generator. During the preparation phase, as you bend your knees to begin the jump, the soleus eccentrically contracts and lengthens, absorbing a bunch of energy to prepare for the jump. Next, during the takeoff phase, the soleus muscle powerfully contracts to create plantar flexion, which is the pointing of your toes down, as you see there, which launches your entire body upward. And then, in the landing phase, the soleus acts as a shock absorber to control the descent, helping to buffer and protect the knee and ankle joints from high impact. Now, that's what the soleus does during jumping. In our next video, we're going to discuss what the plantaris does while we are jumping. Next, for our plantar flexor muscles, we have the plantaris muscle, a small and thin muscle running between the gastrocnemius and the soleus, also inserting at the Achilles tendon. During a jump, the plantaris contracts to weakly assist in pointing the toes, which is called plantar flexion, and it also helps in bending the knee. Because it is so small and weak in humans, its primary purpose is thought to be providing proprioceptive feedback to the brain regarding foot and leg position. So basically, it sends a lot of information back to the brain about where your body is, where your lower limbs are in space. During the preparation phase, as you bend your knees and hips to prepare to jump, the plantaris helps to flex the knee joint. The muscle belly and its long tendon stretch as your ankle moves into dorsiflexion. This stores passive elastic energy in the tendon. In the takeoff phase, as you extend your ankles and knees, the plantaris, acting as an accessory to the much larger gastrocnemius and soleus muscles, contracts and helps to plantar flex the ankle. In this stage, because it contains a remarkably high density of muscle spindles, it acts as a crucial sensory organ. During the explosive propulsion of a jump, it's constantly relaying information to your central nervous system about how fast and where your limbs are moving, ensuring optimal coordination. In the landing phase, as you absorb the impact of the jump upon landing, the plantaris and other calf muscles undergo eccentric contraction to act as a brake, helping to control ankle movement and protect the joints. So the next muscle we'll be talking about is the tibialis posterior. The tibialis posterior is located deep in the calf. Its tendon wraps behind the inside of the ankle to support the foot's arch. The tibialis posterior acts as a critical dynamic stabilizer during jumping. It dynamically supports the medial arch of the foot and works in tandem with other muscles to point the foot downward and turn the sole inward. During the preparation phase, as your knees bend and ankles flex, your foot naturally begins to pronate, which is when it flattens and rolls inward. The tibialis posterior contracts eccentrically to control this motion. It prevents the arch of your foot from collapsing too quickly, acting as a brake to absorb shock and store elastic energy. During the takeoff phase, as you push off the ground, you extend your ankles. The muscle switches to a strong concentric contraction, working alongside the calf muscles, which are the gastrocnemius and the soleus, to plantar flex your ankle, which is when you press your toes into the ground. It simultaneously inverts the foot to lock the midfoot bones into a rigid lever. This rigidity creates a stable platform, allowing you to transfer the maximum amount of force generated by your larger leg muscles into the jump. And lastly, in the landing phase, when your feet hit the ground, high impact forces travel up your leg. The tibialis posterior immediately activates to act as a shock absorber. It eccentrically guides your foot back into pronation to dissipate the ground reaction force. By controlling how quickly your foot flattens, it protects the ligaments in your foot and prevents the ankle from rolling inward. Next, we have the flexor hallucis longus muscle running down the back of the leg and crossing the ankle to flex the big toe. During jumping, the flexor hallucis longus acts as a critical power generator and stabilizer. It drives the final, forceful push-off through the big toe and actively stiffens the arch your foot to transform the foot into a rigid lever, maximizing your upward propulsion. During the takeoff phase, the flexor hallucis longus performs plantar flexion and helps you push off the toe. As you bend your knees and explosively extend your legs, the FHL contracts heavily to point your ankle downward and aggressively flex your big toe. This provides the final vital burst of upward momentum just as your toes leave the ground. It will also act as an arch stabilizer. The FHL braces the medial longitudinal arch to prevent the foot from collapsing under your body weight, allowing you to transfer maximum force from your calf muscle directly into the ground. During the landing phase, when you land, the FHL works in reverse. It lengthens under tension to control the impact, absorbing shock and preventing your foot from violently flattening out or rolling inward. It provides stability. It instantly fires again to re-stabilize the foot and ankle, helping you maintain balance and regain control of your body immediately after the jump. Our next muscle is the flexor digitorum longus. Similar to the flexor hallucis longus, it runs down the back of the leg and crosses the ankle to flex the smaller four toes. During a jump, the flexor digitorum longus actively flexes your toes and aids in pointing the foot downward, which is plantar flexion. This deep calf muscle maximizes your push-off force, provides extra thrust at toe-off, and helps transfer power to the ankle to increase jump height. During the preparation stage, as you bend your knees and hips, the FDL stretches. It preloads with tension to store elastic energy and helps stabilize the arch of your foot so you have a solid foundation to push against. During the takeoff phase, as you extend your ankles and launch into the air, the FDL contracts forcefully. It pulls the second through fifth toes downward into the ground, gripping the surface and providing the final thrust at toe off. While in the air, it helps you maintain balance by keeping the toes slightly curved, and then during the landing phase, it engages with other foot muscles to help absorb the impact and stabilize your foot arch. Next, we have the tibialis anterior muscle, the main shin muscle. It pulls the ankle upward and turns the foot inward. During a jump, the tibialis anterior dynamically stabilizes the ankle and lower leg. It acts as a decelerator to steady the foot before planting, assists in explosive liftoff by pulling the toes up, which is dorsiflexion, and absorbs shock during the landing to protect the joints and prevent ankle sprains. During the preparation stage, as you bend your knees and hips to load up for an explosive jump, the tibialis anterior contracts to pull the foot upward towards the shin. This is dorsiflexion. And then it also stabilizes the ankle. This positioning maximizes your range of motion and creates a rigid, stable foundation, allowing you to transfer force efficiently from your legs to the ground for a higher, more explosive vertical jump. During the takeoff phase, the muscle relaxes slightly but remains engaged in an isometric capacity to keep the foot in a neutral or slightly dorsiflexed position. This keeps your toes from pointing downward, ensuring your leg remains properly aligned to maximize your propulsion and control in the air. And in the landing phase, when returning to the ground, the tibialis anterior performs an eccentric contraction. It acts as a powerful brake to decelerate the foot as it strikes the floor. This controlled descent absorbs the impact before it transfers to your knee and ankle joints, protecting you from injury. Our next muscle is the extensor digitorum longus. This muscle runs down the front of the leg, crossing the ankle to extend the lateral four toes and dorsiflex the ankle. During a jump, the extensor digitorum longus acts primarily as a stabilizer. While the powerful calf and thigh muscles generate the main propulsion, the EDL stabilizes the ankle and toes, actively pulling the top of the foot and lesser toes upward to ensure proper biomechanics and positioning before liftoff. During the preparation phase, the EDL contracts to dorsiflex the ankle. That's what you see here, basically bringing the foot upward. It will also extend the toes, which is what you see here, basically lifting toes 2 through 5. This sets the foot at the optimal angle to load the Achilles tendon and calves for explosive power, ensuring the foot hits the ground in the correct alignment. During the takeoff phase, the EDL briefly relaxes or acts eccentrically to allow the calves and larger muscles, like the gastrocnemius and soleus, to fully extend the ankle into plantar flexion, which is when you're pointing the toes downward. This relaxation allows for smooth, unhindered upward push, giving the body maximum vertical velocity. While you're in the air, the muscle subtly contracts to hold the foot and toes in a slight dorsiflexion. This prevents the toes from dragging and keeps the foot stabilized, preparing your body for a balanced, controlled landing. And during the landing phase, the EDL acts as a brake, helping to control the descent of the foot as the toes strike the ground. This helps absorb impact and stabilize the foot to prevent injury, keeping the joints aligned as you absorb the shock of landing. Our next muscle is the extensor hallucis longus, a deep muscle in the front of the leg that extends the big toe and flexes the ankle upward. During a jump, the extensor hallucis longus primarily acts as a stabilizer. It eccentrically contracts during the takeoff and flight phases to control ankle movement and keep the big toe from excessively flexing, while assisting in lifting the foot. During both the preparation and takeoff phase, the EHL dorsiflexes or pulls up the ankle. It will also extend the big toe. During these phases, it acts as a dynamic stabilizer. By pulling the big toe up, it works in tandem with the flexor hallucis longus to prevent the big toe from buckling, ensuring your foot hits the ground in an optimal position for you to push off strongly. While you are in the air, the muscle subtly contracts isometrically or eccentrically. It keeps the foot stabilized mid-air, holding the big toe straight and helping you keep the toes cleared so that you do not drag if your legs swing forward during a jump or landing maneuver. During the landing phase, the EHL acts eccentrically. When you touch down, your ankle moves into plantar flexion, which is when you're pointing your toes. This would normally cause the big toe to buck or curl. The EHL engages to control this muscle, preventing you from stubbing or injuring the toe upon impact. Next, we have the peroneal tertius, a small muscle originating on the lower fibula that assists with ankle dorsiflexion and eversion. During a jump, the peroneus tertius muscle acts as an ankle stabilizer. As you push off, it stabilizes your lateral ankle, and while in the air, it briefly dorsiflexes and inverts the foot to help position it perfectly for a safe, neutral landing. During the preparation phase, as you bend your knees and hips when you're dorsiflexing the ankle to load power, the peroneus tertius undergoes a controlled stretch. It resists excessive inversion of the foot to keep your lower leg and ankle properly aligned. During the takeoff phase, as your calves forcefully plantar flex to launch your body upward, the peroneal tertius fires to brace the lateral side of the ankle joint. This ensures your foot doesn't buckle and allows you to transfer maximum explosive power through the ground. While in the air and before landing, once your feet leave the ground, the peroneal tertius acts as a dorsiflexor and everter. It pulls your toe slightly upward and turns the sole of the foot slightly outward. This action ensures your toes clear the ground and align the foot into a neutral, flat position to prepare for a stable, balanced landing, which protects the ankle from rolling. The next muscle we have is the fibularis longus, or the peroneus longus, originating at the upper fibula and wrapping under the foot to stabilize the lateral ankle. During jumping, the fibularis longus acts as a critical stabilizer and force transmitter. During the preparation and takeoff phase, the fibularis longus plantar flexes the foot. In doing so, it assists the larger calf muscles in pointing the toes downward to generate the explosive push-off force needed to leave the ground. It will also help stabilize the foot. Because its tendon travels underneath the sole to attach to the inside of the foot, it anchors the big toe down. This creates a stable first ray, ensuring you push off with maximum power rather than the ankle collapsing or losing structural integrity. During the landing phase, just before your feet touch the ground, the fibularis longus fires reflexively to prepare the ankle for the shock of impact. It will perform eversion to provide ankle protection. The muscles sharply contract to evert the foot. This actively prevents the ankle from rolling inward, which is the primary cause of lateral ankle sprains. It will also help with shock absorption. It controls how the foot strikes the ground, managing the arches to prevent the foot from collapsing too quickly while acting as a shock absorber. Our last muscle that is attaching at the ankle and helps with jumping is our fibularis brevis. This muscle starts midway down the fibula and attaches to the outside of the foot to evert and stabilize the ankle. During jumping, the fibularis brevis acts as a critical dynamic stabilizer. It fires to evert the foot and assist in plantar flexion, protecting your ankle from rolling as you plant, take off, and land. For the preparation in the takeoff phase, as you push off the ground to jump, the fibularis brevis contracts to help plantar flex the ankle, working alongside the larger calf muscles to provide the explosive upward force. Simultaneously, it works to evert the foot, stabilizing the fifth metatarsal and preventing the ankle from collapsing inward as you exert maximum power. During the landing phase, when your feet hit the ground, the ankle naturally wants to roll inward. The fibularis brevis fires reflexively to counteract this, providing dynamic lateral stability and acting as a shock absorber to prevent severe ankle sprains. It helps manage the descent of the foot, ensuring that the force is distributed evenly rather than collapsing your weight inward. Well, now you know all about the ankle muscles and the role that each one of them plays in your ability to jump. Hit that subscribe button if you'd like to learn more about your amazing muscles.